Hey everyone, today we're going to talk about the mean value theorem. And so one thing to remember here that's going to help us out is that when we talk about mean, we're talking about the average. And that's going to be important here because when we're talking about the mean value theorem, we're comparing the average rate of change with the instantaneous rate of change. Now, remember also, when we're talking about the average rate of change, we're talking about the slope of the secant line, or what we think of as kind of our regular slope. But when I'm talking about the instantaneous rate of change, I'm talking about the slope of the tangent line which we all know by now, the slope of the tangent line is our derivative. Okay, so here's what's going on with the mean value theorem. There's two conditions, or what we call the ifs. So the conditions or the if. So our first condition is if f of x is continuous on a closed interval from a to b. So those closed brackets mean we include the endpoints. So I'm continuous on an interval, including those endpoints. My second condition is that if f of x is differentiable, or in other words, the derivative is defined on the open interval from a to b. So in that case, we're not including the endpoints, but it means that in every point in between a and b, the derivative exists. So if those two things hold, then here's what we know. The conclusion, or the then, is that then for some value c in the interval from a to b, we know that f prime of c is equal to f of b minus f of a over b minus a. So in other words, we know that the instantaneous rate of change, right, f prime of c is the instantaneous rate of change. We know that's going to be equal to the average rate of change. And in the Desmos activity, you saw an illustration of what this looks like. So if my function is continuous on the closed interval and it's differentiable on the open interval, then for some value c in that interval, I know my instantaneous rate of change is going to be equal to the average rate of change. Now, here's when we're really going to be using this. We use the mean value theorem when we're trying to guarantee that a function has a specific slope. And so here's what I kind of want to bring up. A lot of people think when they hear mean value theorem, they start comparing it to the intermediate value theorem. Remember the IVT we use to guarantee that a function takes on a specific value? But in MVT, we're guaranteeing that a function has a specific slope. So I'm going to make a note here. IVT is to guarantee a specific function value. Just as a side note there. So we use it when we're trying to guarantee that a function has a specific slope, or when we are trying to locate the place where a function's average rate of change is the same as its instantaneous rate of change. So with this theorem, we can actually find the location of that point. All right, so let's go ahead and see what these problems are going to look like. Sorry, that's been all crooked. All right, so here's the first one. It says, given the function f defined here, what are all values of c in the closed interval from 0 to 3 that satisfy the conditions of the mean value theorem? So before we can use MVT, we need to check a couple things. So the first thing we need to check is whether or not this is continuous on our interval here from 0 to 3. So I know this cubic function here is going to be continuous. So we would say our first condition is that f of x is continuous on the interval 0 to 3. I know that this is going to be a smooth curve without any corners or anything. So we also know that f of x is differentiable. On 0, 3. So we've checked our conditions, and now we can actually use the theorem to try to find those values of c. So what the intermediate value theorem, or excuse me, mean value theorem says is that if we've met these conditions, then we know that f prime of c is equal to f of b minus f of a all over b minus a. Well, f prime of c, that's going to be just the derivative of f of x. So I know that's going to be 3 times the quantity 1 minus x squared times negative 1. My interval's from 0 to 3, so I have f of 3 minus f of 0 all over 3 minus 0. Now, I'm going to take this c and substitute it for x. So I'm actually going to have, let's see if I simplify this, negative 3 times the quantity, oops, I had my squared in the wrong place. Sorry about that. Hopefully you caught that before I did. Okay, so negative 3, then I have 1 minus x, quantity squared. That's going to be equal to, let's see, f of 3 is going to be 1 minus 3 is negative 2 cubed is negative 8. Minus f of 0 is 1 cubed, which is 1 over 3, which is negative 9 over 3, or negative 3. So now we're getting close. Now we just have to solve this equation. I'm going to take this up here. I've got negative 3 times the quantity of 1 minus x squared is equal to negative 3. First thing I'm going to do is divide by a negative 3. So I'm going to get 1 minus x. That quantity squared is equal to 1. Now I have to undo the squaring by taking the square root of both sides. So I'm going to get 1 minus x is equal to, now the square root of 1 could be a positive or a negative 1. So we have to be careful to get both of those answers. So now when I subtract, right, I'm going to subtract 1, so I have negative x equals, now if I subtract 1 from positive 1, I'm going to get 0. If I subtract 1 from a negative 1, I'm going to get negative 2. Now when I divide by a negative 1, I'm going to get x equals 0 or 2. All right, so those are our values. Now, what I guess I should have done, I said I was going to substitute for c, and I never did, so technically these x's would have been a c, and then we would have been solving for the values of c that make this equation true. So I apologize for that, but the process there is still the same. Okay, let's look at number 2. All right, so applying the mean value theorem to function g of x on the interval between 0 and 2 guarantees that there exists some value c where c is between 0 and 2 such that g prime of c is equal to which value. So if we apply the theorem, we know the theorem tells us that g prime of c has to be equal to, if we're on this interval, g of 2 minus g of 0 all over 2 minus 0. So if we can solve for this average rate of change, then we'll know the value we're guaranteed to get for the instantaneous rate of change. So if I plug in 2 for g, let's see, I get 12 plus 4 is 16 plus 1 is 17, if I did that right, minus g of 0 is going to give me 1 all over 2, is 16 over 2, which is equal to 8. So by the mean value theorem, I know that if my average rate of change is 8, I'm guaranteed that my instantaneous rate of change will also be 8 at some point on that interval. Okay, let's look at number 3. So number 3 is asking how many of these functions do not satisfy the conditions of the mean value theorem on the interval from a to b. So it's really just testing whether or not you know the conditions of the theorem. So remember, our first condition was that the function has to be continuous on the closed interval from a to b. So that's the first thing we check for. Now, if I look at this one, because of this here, I am not continuous at that left endpoint. So I know this function is not going to satisfy the conditions. The second graph is continuous everywhere along that interval, as well as my third. Now here, because I have this vertical asymptote, I have an infinite discontinuity. I know I'm also not going to meet the condition for that graph. Our second condition is that we have to be differentiable on the open interval from a to b. So differentiable means, right, there can be no corners, cusps, vertical tangents, or discontinuities. And the discontinuities we've already taken care of, so we really need to look for those other three. Now in the second graph, I see here that I've got a cusp happening here, which means my derivative is not going to be defined at that point, so I'm going to fail my second condition. Now the third one, we have to be careful. If this were more extreme, we might be worried about a vertical tangent, but this slope actually, we're going to have a defined slope at every point along that curve, so this function would satisfy the conditions, which means we have 1, 2, 3 functions that do not satisfy those conditions. Okay. Next problem says the function f is continuous on the closed interval. So we know that. And it's telling us that f of negative 2 equals f of 2 equals 0. So essentially we're getting 2 points. So we know there's a point negative 2, 0 and the point 2, 0. So it says if there is no c for which the instantaneous rate of change equals 0, which must be true. So now we know that the mean value theorem says that the instantaneous rate of change must be equal to the average rate of change. So I could do f of negative 2, or actually f of 2 minus f of negative 2 over 2 minus negative 2. So that would give me f of 2 we know is 0, f of negative 2 is 0 over 4. So by the mean value theorem, if the conditions were true, it would mean there is a c for which f prime of c equals 0. If that is not the case, there is no c, that means one of the conditions of the MVT have been violated. So essentially, if that is not true, there's no value of c where my instantaneous rate of change is equal to 0, means either that function is not continuous on the interval or it's not differentiable. So I'm looking here and I see a lot of references to the derivative. So that tells me that the function is not differentiable. Probably I'm looking at this condition. So we're not differentiable on the interval from negative 2, 2. So I'm going to look for an option that's telling me I'm not differentiable. So if I look at choice E, it's telling me there's a point in that interval where the derivative does not exist. That means I'm not differentiable, and that explains why I cannot guarantee that the instantaneous rate of change equals 0. Okay, one last problem. So this says the continuous function f is defined on the interval from -4 to 3. We have the graph of f has 2 quarter circles, so a quarter circle here, and then one line segment. So first thing, it asks us to find the average rate of change on the interval from -4 to 3. So I know the average rate of change is going to be f of 3 minus f of -4 all over 3 minus a -4. F of 3 gives me a -3. F of -4 is a -1, and then I have a +7. So that gives me an average rate of change of -2 over 7. Now, it says there's no point C in that interval for which the instantaneous rate of change is equal to this value. And it asks to explain why this statement does not contradict the mean value theorem. Now we have to think back. The mean value theorem, again, has those two conditions. The first is that we're continuous, which this function, looking at the graph, is obviously continuous. So we know we meet that condition. However, the second condition is that we're differentiable. And if I look here, I know I have kind of a corner point there that's going to make me not differentiable. So we could say this does not contradict the MVT because f is not differentiable on the interval from -4 to 3. Okay, so that's the MVT, and we'll be working some more with this. I am sure there are going to be some questions about this, and we'll talk about all that when we're back in class. Thanks.